All right, so again, Unit 4 is going to be systems in 3 variables, and then we're also going to add matrices. So we're still working in systems, but before you guys were working in systems in 2 variables for equations and inequalities. Now we're going to be working in 3 variables. So we'll have more than just x or y. We're going to be dealing with x, y, and z. So 4.1 notes look like this. And all we're going to be talking about in 4.1 is what these graphs are going to look like in 3 variables. Okay, so graphs in 3 dimensions. And it's the 9th today. And this is 3rd hour. And our goal today is going to be to graph points and equations in 3 dimension, so in 3D. So before, the old stuff, when we worked in 2 dimensions, a point on the graph was called an ordered pair. Or coordinate point, okay? And we graphed that ordered pair on the coordinate plane. Okay. There were 2 axes. You had an x-axis and a y-axis. And then we would write the point x, comma, y. Now when we are working in 3 dimensions, we're not going to have an ordered pair. Instead, it's going to be an ordered triplet. It's not going to be a pair anymore. A pair would only be 2. So it's going to be an ordered triplet. Or an ordered triple. Ordered triples. Okay. And when we graph this, if we have 2 axes that make a plane, what would 3 axes make? Anyone want to guess? What is it? Oh, no, it doesn't make makes a space. Okay, so 2 axes are going to make a plane. If I go in a third, add a 3rd axis, I've now created space. So this is going to be plotted on the coordinate space, no longer a coordinate plane. Okay. We no longer have 2 axes, we're going to have 3 axes. And our ordered triple is no longer just going to have an x, comma, y, it's going to be comma, z as well. So we are going to describe and then graph the location of each point in the coordinate space. So your x-axis, this moves forward and back. Your y-axis moves left and right, and your z-axis moves up or down. Okay? The z-axis, if you're moving up, this is positive. If you're moving down, that's negative. Your y-axis is the same. It's not the same as a y-axis before. It now looks like the x-axis. But if you move to the left, that is going to be negative. If you move to the right, that's going to be positive. Okay? If you start here, okay, at the origin, this is still called an origin. If you move forward, you're going to be coming, like, some people get confused and they don't know what's back and what's forward. We consider this is your positive direction, and we call this forward. Okay, positive goes forward. If you're moving away from like where we're standing, that's backward, and this is negative. Okay, left, right, up, and down are pretty self-explanatory, but positive is forward and negative is backward. Is that okay? All right, so it goes X, Y, and then Z. So if you're moving from the origin, to have to go to 2 on the X would be going forward 2. Your Y is then 3. It's a positive, so on the Y, positive moves to the right. So this goes right 3. The 4 is your Z. 4 positive is up, so I'm going to move up 4. So the first number is always going to be forward or back. The middle number is always going to be left or right. The last number is always going to be up or down. Okay, so that first number, forward or back. 0. How does that one move? It doesn't matter. You could say 0 forward, you could say 0 backward, because if you're not moving forward or backward, you're not moving. Okay, so I don't care if you say 0 forward here or backward. Just tell me you're not moving forward or backward. Okay. That middle one, how's this one going to move? Right 1. Very good. And that last one is a -5. How does that one move? Down 5. Give me a 1 through 5. I'm catching on what we're doing here. Down to a 1. Whoa, what the heck is going on? How about the right side of the room? I didn't see your hands. 1 through 5. Where are we at? Okay. I want you guys to try this last one. Try this last one on your own. So that moves 3 backward, 2 to the left, and 4 down. I don't care if you write backward 3 or 3 backward. It does not matter to me. As long as you have the word backward and the 3, I don't care the order. So far, so good. Now, we're not done yet, though, because we did not plot these. It says to graph them. I have to still graph them on this lovely coordinate space. Okay? We are just going to plot here. We'll have 3 points. Sometimes it gets a little confusing if we plot more than 1 point on a graph at a time, but that's okay. I'll color coordinate them so we can see them a little bit easier. First thing we have to do is whenever we graph, we have to have scales on our graph. So I'm just going to have a scale of 1 on all of these. So, yeah, except to 5. Actually, we should be able to do halves. So this will be 1, 2, 3, 4, 5, 6. Yeah, so we have to go, the highest number is 5. So at least that'll space things out a little bit more. -1. All right, so here are my scales. Okay. Now, I hope you didn't move forward because a lot of people tend to really struggle with this. So it's important. What I'm going to do first is I'm going to walk you through it first. I want everyone to put your pencils down and just watch. And then I will do it with you. Okay? So, there are 2 options. Because this is a space, you are just plotting 1 point. However, sometimes if you draw a box, it makes it a little bit, because boxes are 3D, it might make it a little bit easier to see where these boxes are. Now, just as a reference guide, some people like to draw their boxes as like a square here, or maybe it will be a rectangle, and then connect all their corners, right? Have you guys drawn boxes like that before? So I'm going to kind of show you how you can draw a box. And then what will happen is once you have your box on there, one corner, and you'll have to identify that corner, will be the point that we're actually plotting, because we're only plotting one point here. Does that make sense? Okay, so I'm going to walk you through the first one, A, 2, 3, 4, and I'm going to show you how I would draw my box, and then I'll walk you through it a second time, which you guys will also join in and actually draw. Does that make sense? So I want everybody to just put their pencils down and watch this time. So if I'm going 2 forward, I'm going to go to the 2 on the X, okay? So I'm going to draw the base of my box first. I'm also going to the right 3. So to the right 3. Now where those two meet is going to create the bottom of this box. Now when I extend those lines, when I go to the right, that's going to run parallel to the Y. When I run forward, that's got to run parallel to the X. Do you see that? Okay. Then I'm also going to have to go up 4. So I'm going to go this far up from all of those corners. Okay. But sometimes it might be easier if you draw the back of the box first. So I've drawn the bottom. Now I'm going to draw the back. Nope, that's not parallel to going right, so I'm going to fix that. It's got to come all the way to the 3. So there's the back of my box. I can draw the top of my box. And right now I have the back and I have the bottom. And from there you're just going to fill in the rest of the sides by drawing the sides, the edges I should say, that are parallel to these axes. And then there's the front. So there's my box. So that'll kind of help us decide how or where that one singular point is now that I have a box to represent that space. So if I go 2 forward to the right 3, now that will tell me how far right 3 is, and then going up 4, this corner right here is actually the point that I'm plotting. Okay? Now, do you have to draw the box in order to plot that point? Not necessarily. If I was doing this on a quiz, I will ask you to plot one point on a coordinate space because I wouldn't ask you to plot multiple. Okay, you could choose to draw that box, but if you don't draw that box, what I'm going to do is with my red pen, I would draw that box in and make sure that point's an actual accurate spot. Does that make sense? And that spot is actually pretty hard to find unless you draw in that box. Okay, so pick up your pencil and then I'll draw it with you. All right, so starting here, we're going to go forward 2. So I'm going to make sure that line's on my graph. Coming forward 2. I'm also going to make sure that I go to the right 3. When I go to the right 3, that's half of the bottom of my box. I'm going to extend from the forward 2, going to the right 3, make that parallel to the y-axis, and coming forward from the 3 on the y, making it also parallel to my x-axis, I'm going to come forward, and that'll create the bottom of my box. From there, I also know I'm going to have to go up 4. Another way you could do this is when you measure up 4, you could say, okay, that is 2.3 centimeters, and then come from the bottom of your box and go up 2.3 centimeters every time. And come from this bottom of the box and just make sure that you are doing this so that it's parallel to that z-axis, and you can come up 4 from all corners of the bottom of your box. that same amount if you wanted to use a ruler. From the 4, you know you're going to come forward. That's going to be parallel to the x-axis there. You know that you can see the front of your box, almost. So you just have to close the front of your box by we're now drawing in the top of our box. You know that the back of the box has to be drawn in. And you know that the edge on the top to the right has to be drawn in. Now, this box is showing us where the space is, but we have to actually point out the one point that we plotted here. So, using the box, we're now coming forward 2. We're going to go to the right 3. And when we go up 4, this point right here is the point that we plotted. That is the point 2, not 3, I don't know why I heard 3, 2, comma 3, comma 4. That's the point 2, 3, 4. Okay. Now, B is a little bit easier because I'm going to put this in another color. I'll do green this time. You're not moving forward or back at all. So if we're going right 1 and down 5, that's just right here. That's almost like plotting on the XY axis because you didn't have to move forward or back at all. Since you're just going left or right and up or down, this point here is the 0, 1, negative 5. That one's a very easy one to plot because of the 0. You don't have to go forward or back. You're just going to the right 1, down to negative 5, and that's your point right here. Make sure you show it as an actual point. Okay. Now the very last one I'm going to draw in there as well. I'm not going to draw it as a box. I'm going to show you how you could also do this without drawing a box. Going 3 back. So backward 3 is to here. 2 to the left. You're going to have to kind of measure this. It's about a centimeter, so I'm going to go about a centimeter to the left here. And then I'm going to go 4 down. So 4 down from there would be about 2.2 centimeters. So from there, I'm going to go about 2.2 centimeters down. And right here would be the point -3, -2, -4. But notice that that doesn't necessarily appear like it's back to the left and down. It almost looks like it's right on that z-axis. That's why it's important that you draw in the arrows of the directions that you're going so you can kind of see that 3D space. Now again, this looks really messy because we just did 3 points on one graph. I will not ask you to do that on an assignment or a quiz. We'll only ever give you one, and I'll give you a separate graph for each point that you have to plot. Does that make sense? Yes, go ahead.
So, for the A example, is it -2, 3, and 4?
It was +2, 3, 4. It was 2 forward. It's on the front of the box. And the front of the box, if you look at it, it's at +2. So if you were given a box and you have to identify the point, from here, look and see, okay, this is against that z-axis right here. So how far forward did it go? It went 2 forward. Your x-axis, that box is hitting on the x-axis at 2. So x has to be 2. On the y, that box is hitting at 3 on the y. And on the z, that box is hitting at 4, which I erased, at 4. So your z has to be at 4.
So it's not the actual point of the graph?
It's not like find z and it's between 2 and 3. It's not like find y, it's between 1 and 2. It's not find x. It's you have to visualize this as a 3D figure. So you have to think about it as if it was not on a flat piece of paper. Is that okay?
Yeah.
Okay. Can I flip this over? All right, so sketching a graph of an equation. Okay, now if we go to an equation, when you graph an equation on a 2D, on a coordinate plane, so when we're working in 2D, I'm like super zoomed in here. When we're working in 2D and we graph an equation, what do we graph? Like y equals 3x plus 4. What does that look like on a graph when we're graphing in 2D? Like a line, right? So if it's 2D, then we graph an equation, makes a line when we're working in linear equations. Okay? So if 2D, it creates a line, what would 3D create? Not a box, not a space. A point, line, and then what comes next? Because a point is like no dimension. A line is one dimension. What is it? Or a plane. Okay, it would make a plane. A point, and then a line, and then a plane. And then space. Okay? So a plane is something that is two-dimensional. So when we go to graph an equation, it's now going to represent a plane. We are going to draw it as a triangle. So you were correct there. It is kind of like a triangle, but the triangle is going to represent a part of that plane, and we'll know that it extends forever in all directions. Okay. So our step 1, when we go to graph this, what we're going to do first is we have to find all 3 intercepts. On an assignment or a quiz, you will have to show me what these 3 intercepts are, and you're going to write them as x, 0, 0, or 0, y, 0, or 0, 0, z. So you're going to have to find and show me what all 3 intercepts are. An x-intercept is where x is a number, but you don't move left or right or up or down at all. You only move forward or back. The y-intercept is only moving left or right. It's not moving forward or back, and it's not moving up or down. The z-intercept is only moving up or down. It doesn't move forward or back. It doesn't move left or right. Okay. Step 2 is to plot the intercepts. Now, plotting intercepts is actually easy because you don't have to draw a box or anything. You just go right to that axis and plot the 1 point on the axis. Okay, so plot all 3 intercepts. Step 3 will be to connect all 3 intercepts to see the plane. So we're going to try this. We have an equation here. Okay, most of the time when we're given equations, a lot of times they're in standard form. Something x plus something y plus something z equals a number. Okay, so our x-intercept, we're going to find that one first. The x-intercept is written as x, 0, 0. So what I'm going to do is I have to fill in the zeros and find x. 3x plus 4 times 0 plus 2 times 0 equals 12. Well, what's anything times 0? 0. So this turns into 3x equals 12. What does x have to be? X is 4. X equals 4 is not an intercept. In this case, that is actually a plane. So I need to write it as this point. So I'm going to come back up here and I'm going to write my x-intercept is 4, 0, 0. Okay, that's one of my intercepts. Then I'm going to move on. I'm going to also find my y-intercept. My y-intercept is 0, y, 0. I'm going to fill in my zeros. 3 times 0 plus 4. I'm looking for y, so I'm going to leave that as y. Plus 2 times 0 equals 12. Well, this goes away and that goes away because both those turn into 0. 4y equals 12. What does y have to be? 3 this time. I'm not going to leave it as y equals 3. I'm going to instead write the point 0, 3, 0. I still have to find my z-intercept, which is 0, 0, z, which is 3 times 0 plus 4 times 0 plus 2z equals 12. The terms with 0 go away. 2 times what number gets you 12? I can't leave my answer as z equals 6 though, because that's a point 0, 0, 6. Okay, when you go to graph these, I will tell you I'm not looking for all this work. You do not have to show me all of that work. But what you do need to do is right next to the graph, you need to tell me the intercepts. I just walked you through that work so you know where it comes from. But next to the graph, what I'm looking for is you to tell me the 3 intercepts. Now on your quiz, you will be expected to do this. And if you write x equals 4, y equals 3, z equals 6, you'll lose 3 points. The x-intercept is 4, 0, 0. If you're moving on and you're not listening to what I'm saying, then you'll probably get that wrong on the quiz because every single year I mark down probably half the class for writing x equals 4, y equals 3, and z equals 6. That would not be acceptable on a quiz because those are not intercepts. Intercepts are points. X equals 4 is a plane when we're talking about it in 3D. Just like in 2D, when we say x equals 4, that's a vertical line through the x-axis at 4. It does not represent the intercept as a point. Okay, so 4, 0, 0. The y-intercept is 0, 3, 0, and the z-intercept is 0, 0, 6. I also need scales on my graph. Many people are still losing points on quizzes because they're not putting scales on their graphs. Every graph needs scales. I'm just going to make my scales go up by half so every other line is 1. And then what I'm going to do is I'm going to actually go through and label each of my intercepts. So my x-intercept is at 4, 0, 0. That means I move 4 forward. That's my x-intercept. I don't move to the left or right, and I don't move up or down. I just go 4 forward, and that's where that point is. Okay, this is the only kind of graph that I'll ever ask you to plot more than 1 point because these points being intercepts are easy to plot and you don't have to go and draw your boxes. 0, 3, 0 is the y-intercept, so it has to hit on the y-axis. I don't move forward or back. I stay at the origin. I move to the right 3, and then I don't move up or down, so that's where that point is located. 0, 0, 6 doesn't move forward or back. It's not going to move to the left or right. It's just going to move up to 6 on the z-axis. So there's that point. Are we okay with how I came up with those 3 points to plot? Okay. Do we see the difference between these 3 points? And on the front side, we only plotted 1 point. Okay. So when I go to actually graph this plane, how I'm going to draw it is I'm just going to draw the lines that connect all of these. So here's a line that goes through those 2 points. Here's a line that goes through these 2 points. And here's a line that goes through these 2 points. And then I'm going to shade this in so we can better see what that plane actually looks like. This plane, this is just a small portion of the plane. The plane actually is extending forever in all directions, which is why it's important that you have these arrows that show you that it goes forever in all of these directions. Because that's just a portion of this plane. We are just representing a small portion. There's no way for us to represent the entire plane because a plane goes on forever. And we cannot spend the rest of our lives attempting to draw a plane that goes on forever and never reach the end. Okay, that'd be silly. That's a silly way to spend your life, so don't do that. Okay, so we represent a portion of the plane, and we understand that that plane continues forever in all directions. Questions on this? Yes, go ahead.
So sometimes you draw squares, sometimes you draw triangles, and I'm going to get that.
Okay, so this we drew a plane. Okay, so we had to draw 3 points because in geometry you learned, there's a postulate, it says any 3 non-collinear points makes a unique plane. So you drew the 3 non-collinear points, points that you cannot connect using a straight edge, okay, because there is a plane that goes, a unique plane that goes through those 3 points. We drew that unique plane, okay. The page before, we were plotting one singular point. That point was not on an intercept though. And so since this was not on an intercept, we had to figure out, we used the box as a visual to see if the point was in front of this y-axis or behind the y-axis. We had to use the box to visualize because this one point we plotted, if it was above where the x and y axes were, so above in the positive direction on the z, or was it below in the negative direction on the z? When we drew this box, we only plotted one singular point. It just takes a lot of work to plot that one singular point because we're working in 3D, and the box helps you identify if your box is on the left or the right, if it's up or down, or if it's forward or back. So it's not that we plotted a box. We plotted one singular point. The box was to help us identify where that one point was. Here's the one point we plotted. Do you see the difference between a plane and a point? Okay, because that's what we plotted, a plane versus a point. Other questions on this? All right, so let's take a look at the assignment then. On the assignment, you have 3 points that you have to describe where they're going. Okay, so forward, back, left, right, up, or down. You have 3 points that you have to actually plot. Okay, so this should have 1 point, this should have 1 point, this should have 1 point. Drawing a box will help you plot those points. For 7 through 12, you're going to use this picture down here to identify. On here, it shows you that this is going to be your x-axis moving on this direction. This is your y-axis moving in this direction. And this is your z-axis, okay? These 2x4s, what it looks like appears to be, okay? Those will help you because anything on this first 2x4 looks like if this is 40, this would be 20, which makes this first 2x4 10. Anything hitting on this first 2x4 would be at an x of 10. If it's that far into the room, then x would be 10. If it's this far into the room, at the second one, your x would be 20. So you have to use those, the different pieces of wood to figure out where in the room is that point located to come up with the actual coordinates. Okay? 13, 14, 15, and 16. Now this is where I was saying many people will lose points. If you write x equals something, y equals something, z equals something, you lost 3 points automatically. Because intercepts should look like what? A point. So you need an ordered triple here. Something, comma, something, comma, something. And it would look like this. Okay, that's what all these intercepts should look like, our points. Ordered triples. Not ordered pairs, because we're now in 3D. Okay? So your first step is to find the intercepts, then you're going to plot them, and from there you should have planes on all of these. Okay? You have until lunch to work on this.